Hello viewers, we are going to look at trusses, and under trusses we are going to consider joint method 1. And because I'm going to solve more problems on the joint method, that is why I'm using joint method 1 for the trusses. So for the question we're asked to, for the truss ABC, I will find the forces in the members. Okay, should be forces in the members BA, CA, and BC. That is BA, CA, and BC. And so before we find the forces, we have to determine the reactions. Before you find the forces in the members, you have to determine the reactions. But I'm not going to do it in this video because already I've done a video on how to determine support reactions in trusses. So you look for that video and watch it so that you understand. So by calculation, we'll have that RB will be 7.5 kilonewton and RC will be 2.5 kilonewton. At this point, since we've been able to determine the reactions, like I said, I'm not going to show you how to determine the reactions because I've done that before in my video, so you check out for it. So at this point, let's name these members. We can call this member 1. We can call this member 1, we can call this member 2, we can call this member 3. Now of course you also know how to use the method of if it is a perfect frame, how to find the member. I've done a video on that. So for joint B, this is joint B. We want to consider joint B, and this is joint B is like this and down. So in joint B, we are going to have A, we are going to have B, we are going to have C. So that is what is represented here. This is joint B. We have A, which is here. We have B, and we also have C. And this angle is at 60 degrees. So that's why we're having here at 60 degrees. And I've also made a video on how to do resolution of forces. So I'm still going to repeat it. So at this point, we have to resolve the forces vertically and horizontally in order to determine the forces in the member. So at this point, we have from here to here. I said when you want to resolve forces, the method I like using is take the arrow. Your angle will be taken from the positive side of X down to where the force is. So for force A, BA, for force C, BC, is at 0 angle, so that one is 0, is certain. Now for force BA is at from the positive side of X to where the force A is, we have it to be 60 degrees, so that is 60 degrees. And then for this other force, for 7.5 kilonewton, we are moving again from the positive side of X down to where the force is, and that will give us 270 degree. So having it to be 270 degree. So that is it. Having done this, we can now resolve our forces vertically and horizontally. So for vertical resolution, we have that BC as the force in BC multiplied by the angle in C is 0. So that's why we're having BBC as B, B, and C. We multiply it by the angle in C, which is 0. And because in vertical, when you are resolving vertically, you use sine. Plus, the next one we are going to consider is the force in member BA. The first one was the force in member BC, and C is inclined at 0 degree. BC is at 0 degree, so that's why we are saying times sine 0. Plus, the next one is the force in member BA, and so it is inclined at what? 60 degrees. That's why we're having PBA times sine 60 degree plus. And the last force is 7.5, and it is inclined at 270 degrees. And so that is why we have it to be 270, and we equate it to what? 0. We equate it to what? 0. We are equating it to 0 because already we have our own convention here. We've made a mathematical statement here that summation of vertical forces equal to summation of horizontal forces will be equal to what? 0. Resolution of these forces equal to this, equal to 0. So that's why we've equated it to 0. And so when you say PBC times 0, it will give you 0 because sine 0 is 0. Then sine 60 is 0.866. So when you multiply this by this, it will give you, okay? And then sine 270 is minus 1. And so when you do this mathematics, you are going to have 0.866 PAB, because this times this will cancel out because since it is 0. And then you minus 7.5, because 7.5 times minus 1 will give you minus 7.5. And so since you are looking for PAB, you make PAB subject of the formula. Definitely when you do that, you are going to have 7.5 divided by 0.866. And your answer is going to be 8.66 kilonewton. Because it is positive, it is compression. So we can go to where the member PBA is and we give it a sense. So because it is compression, so this is where our arrow will be. Now, when we are done with that, we can now resolve horizontally using the same diagram, because each diagram you resolve vertically and horizontally until you've exhausted the forces in all the members. So the same thing goes to the horizontal component. So in horizontal, we are using cos. Every other thing remains the same. The angle between B and C will remain the same as 0. The angle between B and A will remain the same as 60 degrees, and the angle between 7.5 kilonewton and the right axis, the positive right axis of x will still remain 270 when you are resolving it horizontally. So this will be PPC, the same thing we had here, but what changes in the horizontal is just that we are using cos, cos, cos. Okay, so when we do that, cos 1 will be, cos 0 is 1, cos 60 is 0.5, and cos 270 is 0. Why is it 0? Because we are resolving horizontally, but we are considering a vertical force at this point, so it will definitely give us 0. That's the beauty of doing this method, because it takes care of quite a lot of things. And so this, since this is 1, this will be PPC times 1, this will give us PPC. This times this will give us 0.5p, and 7.5 times 0 will give us 0. So because recall that our PBA is this value, so we bring it into here, and so we have this to be PBC plus 0.5 into 8.66, because our PBA we've calculated it and we had this value. And so when we do the mathematics, we end up having PBC to be equal to minus 4.33. So it is either you leave it at minus 4.33 or you remove the minus and indicate that it is tension. Once you write tension, anybody looking at it will understand the fact that yes, it was actually negative. And so we've gotten PPC, the force in BC, and since it is tension, this is how the arrow, your arrow will be. So you now include this arrow here. It is now tension. So we are done with joint B. So we now look at the next joint, which is C. And so this is how we have it in the diagram, joint C. And let's call here will be C. This is C. This is joint C. So this is the joint from here down and then from here down. So that is joint C. And so since we've gotten this, we still do the same thing we did to joint A. First, we have to determine the angles so that we can do a resolution of forces. And so to determine the angle between B and C, okay, let's look at it. First, we have to take this one down to where the force is, that is between force CA or member CA, you can call it member CA. If you take it from the positive side of X down to where the force is, it's going to be 150 degrees. That is because at this point, we have these two. If it goes up straight, from here to here will be 90 degrees. And so having crossed this point, we know that after the 90 degrees from here to here is another 90 degrees, making it 180 degrees for angle in a straight line. So but then we have this one cutting out here, and we are told that from here to here is 30 degrees. So if the all of this is the all from here to here is 180 degrees, and we've taken out 30 degrees, it means the remainder will be 150 degrees. So the angle between member CA will be 150 degrees. So we do the same thing, moving from the right and the positive right hand side of X down to where B is. So that one will give us a complete 180 degrees because it is angled in a straight line. And then the next one is to move it down to where this other force 2.5 kilonewton is. 2.5 kilonewton. 2.5 kilonewton. So we move it from this point to the force, and then that one will give us, because from here down here is 180 degrees plus 90 degrees. This is acting at a straight line down at this point, plus 90 degrees. That one will give us 270 degrees. Having done that, we can now do our resolution of forces. And so the first one we want to do is to resolve the forces vertically. And so when we do that, we are going to take the force in CA, that is a CA, the force in member CA multiplied by 150 degrees. And because we are considering vertical direction, so it will be 1 sine 150, because that's the angle between C and member C and A. And then the next one is PPC, that's the angle between this member B and C, or C and B, depending on how you want to put it. So because the angle between them as from C to B now is 180 degrees and is vertical, so we have PPC times 180 degrees. We do similar thing to this, and so this is 2.5 sine 270 degrees, because if you have to move from this positive side of X down to where this force is, it will be 270 degrees. So when you do your own calculation mathematically, you are going to sine 150 is 0.5, so you multiply it by CA, PCA, that will give you 0.5 PCA, plus sine 180 is 0. Sine 180 is 0, so that will give you 0 here. Sine 270 is minus 1, so you are going to have 0.5 PCA minus 2.5 equal to 0. It is minus because sine 270 is minus. So we continue the calculation from here. And so if we have, it means if we move this to the right hand side, we are going to have 0.5 PCA equal to 2.5. Because we are looking for PCA, we divide both sides by 0.5. So we say divide both sides by 0.5. When we do that, we are going to have 0.5 PCA divided by 0.5 equal to 2.5 divided by 0.5. So our PCA, when you divide 2.5 by 0.5, it is going to give you 5. So you have 5 kilonewton to give you 5 kilonewton. Sorry. Okay, let's check kilonewton. So 5, oh, we should have had kilonewton here before the tension. Let me use a red marker for it. So tension, because the answer was negative. So we have 5 kilonewton, and because the 5 kilonewton is positive, we'll call it compression. And so we can come to our, this is CA, PCA is compression, so the arrow will be like this. So we don't need to do the horizontal part again because already we have the value for BC that we've calculated already, and that's the value of BC. Okay, where yeah, PBC. So we don't need to do for this one again because we've had the value, we've calculated for it already. So at this point we can now present our answers. So we have serial number, that's the number of the member, we have the member, we have the force, you can say magnitude of force, and then you can say the nature of force. So remember we have this, we had 3 members, so we are going to have 1 2 3, 1 2 3. Now if you recall from our diagram, we had B here, we had A here, and we had C here. So from our diagram, we call this member was 1, this member was 2, and this member was 3. So the member, this is the one that is member 1 is BA, so we represent it using BA. Member 2 is BC, so we represent it using BC, and member 3 is CA, so we represent it using CA. So the magnitude of the force, as the size of the force for PBA was 8.66, and the nature of the force was compression, so we write C. Then for BC was 4.33, and the nature of the force was tension. Note during calculation this is negative, and that's why we're writing tension. So if you put the sign tension, the symbol tension, you shouldn't add negative again. Now CA is 5 kilonewton. Okay, we can say the magnitude of force in kilonewton, and the nature is C, compression, because the answer was positive. So basically this is how to determine use joint method to determine the forces acting on the members of a beam. You watch out for my next video on joint method. I'm going to do a question that is a bit more complex than what we've done. Thank you.